Hi, I'm Ramya. Welcome to X Beyond 360's educational series. In this video, we discuss parallel versus series circuit theory. Let's begin with a parallel wiring example. You can see here how batteries are wired in a parallel wiring configuration. The individual battery terminals are connected positive to positive and negative to negative in strings of up to 4 batteries. When wired in parallel, the voltage remains constant, but the capacity increases. In this example, two 120 amp-hour batteries total 240 amp-hours at 12 volts direct current. Let's go to our series wiring example. In a series wiring configuration, the individual battery terminals are connected positive to negative in strings of up to 4 batteries. In series, the voltage increases, but the capacity remains constant. In this example, two 100 amp-hour batteries total 100 amp-hours at 24 volts DC. We are using a bus bar here, as well as in the previous parallel example. Bus bars are your preferred method of connection, as opposed to interconnecting wire-type cables. Wire interconnections are susceptible to loose connections, loose lugs, and unequal lengths, all of which add up to additional resistance, resulting in heat and higher voltage drops. When wiring batteries in parallel, the following effects will take place. The energy measured in watt-hours will increase incrementally by the amount held in each battery. The capacity measured in amp-hours will increase incrementally by the amount held in each battery. The voltage measured in volts DC will remain the same as the rating of the individual battery. The current measured in amps will increase charge or discharge rates incrementally by the amount held in each battery. When wiring batteries in a series, the following effects will take place. The energy measured in watt-hours will increase incrementally by the amount held in each battery. The capacity measured in amp-hours will remain the same as the rating of the individual battery. The voltage measured in volts DC will increase incrementally by the rating of the individual battery. The current measured in amps will maintain charge or discharge rates by the amount held in an individual battery. For parallel wired battery banks, we recommend that it is best to pick up the positive terminal at one end of the single parallel string and the negative terminal from the opposite end of the string. This is done in an attempt to balance the amount of current and voltage running through the string during charge or discharge. Feeding the string from one end can cause a voltage or current imbalance, which is why we don't recommend using that configuration. Each pair of interconnecting cables will introduce additional resistance until the last battery ends up with the highest resistance path to the attached load. The buildup of resistance causes the first battery to be overworked, discharged at a higher rate, and overcharged. It will most likely fail prematurely. Additionally, make sure your interconnecting cables are of equal length and gauge. If possible, use bus bars as shown here. To view other product videos, user manuals, and specification sheets, visit xbeyond360.com.